So we're going to try practicing solving quadratic equations. 3 methods, basically with factorising. If you get a letter in front, a number or a coefficient of x squared, a number in front of it, the x squared here, yes, you might need to use the formula to do it. We'll have a little talk about that when we do the formula. But to factorise this, what's the basic rule with the quadratics? What must they look like for us to be able to solve them? To be able to solve a quadratic equation,
they should equal to 0.
Must equal 0, because what we're going to try and do, and all the methods rely on this in some way, is saying that these two things, when you multiply them, they're going to give you 0. So the first thing, bring everything to the left-hand side to make an expression. Okay? What's the rules then, using the numbers, the coefficients?
X, like, it's 1, and it's 8, and then 3. Oh, wait, it's
We're not using the formula, we're going to factorise first. So which bits do we look at? We've got a -3 and we've got a +2. What must happen?
Should divide the two to its multiple.
We're trying to make the multiple, the 2 brackets that this creates. Don't need to divide by 2 because this x squared is fine. What we're looking for are 2 things that multiply to give us 2 and add to give us -3. Because if you remember what the bracket looks like, you do 2 brackets. You've got an x in the first part, x in the second part. When you multiply these 2 things together, that gives you the number term. When you multiply this one by that number and that one by that number, they're going to combine because they're both x terms, so they're going to add. That's what this is based upon. So what possibilities have we got for numbers that multiply to give me 2? 1 and 2. They would work. So if I put 1 and 2 here, do they make -3? So what?
1 plus.
Oh, wait. Change all the signs going backwards and it would work. So we now create our 2 brackets. X, and the first thing it's going to multiply by is the -1. Notice if you were dealing with this as with a coefficient in front of the x, it is quite important you think about this x multiplies by this number to give me the -1x here, and the -2. Remembering these are in opposite pairs. That equals 0. So what's x? What possible values could I get for x? Yeah, so we say each bracket is equal to 0, and we get x is 2 or x is 1. You can do a check, you can try putting the numbers back in. So do a little check. If I do 2 squared minus 3 lots of 2, x squared is 4 minus 6, so it's 4 minus 6 is -2. That worked. And we put in the 1. 1 squared minus 3 times 1 is equal to 1 minus 3, and that equals -2 as well. So it works. Both those solutions both work. Yeah? Give me a number 1 to 20. 19. Let's look at question number 19 then. I just want to change the colour up here, back to black. Question 19 is slightly over to the side there. So it's x squared plus 5x plus is equal to 15. We'll think, can we do this by doing the factorising?
I'm doing factorising here.
We'll see. X squared plus 5x equals 15. What must I do first?
Make sure it equals to 0.
Yeah, rearrange so that it must equal 0. 2x squared plus 5x minus 15 equals 0. So I'm now looking for what? What's the thinking? Sorry, that should be in a thought bubble as well. What are we thinking about?
The multiples of -15 add up to 5.
Yeah, so we want multiples of -15 and the sums of them must equal 5. So what numbers could multiply to give me 15?
1 and 15.
115. One of them would need to be negative. Let's put the minus in that one. What else could happen?
3 and 5.
3, 5. One of them needs to be negative. Do either of those, when I add them now, give us 5?
No.
No. Do they even give us minus 5?
No.
No. So factorising probably is not a good idea. So factoring failed. Here's the big bit of memory. So we've got a different thing we've got to do. You wouldn't normally put these bits in, so I'm going to write it in red. To use the formula, what must I know for formula?
Discriminant.
Okay, you're going to go by the discriminant method. How do I calculate the discriminant?
B squared minus 4ac.
That's the discriminant. What's A, B and C?
A is 1.
Yeah, so A equals
B
1.
is 5. And C is minus 15.
So that's...
The formula longer.
The formula is longer, but this gives us the discriminant. As you use it, okay, we'll use it, and then we'll talk about the formula in a minute. So my discriminant, which I will do in blue, so D equals B squared, 5 squared, minus 4 times A, 4 times 1, times minus 15. 5 squared, 25. Minus 4 times 1 times 15, minus 15. 4 times
Plus 60.
plus 6, so it's going to be a minus, so it's a plus 60. So my answer is 85. That's the first part of it. So that number is a positive number. What's that positive number say for my discriminant then?
You can square it. Oh, it has the square root.
It has 2 solutions.
Wait.
Yeah. If that's 0, what's it mean?
1 solution.
1 solution. If it's negative,
0.
no real solutions. Okay. So we now need to do the rest of the formula. What's the rest of the formula say?
It's a minus x. Minus b plus minus square root of g.
Missing something.
B. A.
Divide by 2 a's. Yeah, that you must know. So you can either learn the full thing as one thing, or discriminant and then do minus b plus or minus square root of d divided by 2a. Stick those together and you will need a calculator. Where's my wasn't that one? It's that one. So my xn solutions, xn just means that I can have multiple solutions. I've got minus 5 plus or minus the square root of 85, all divided by 2. Calculators, let's see what's going on. So negative 5. Let's do the positive version first, plus the square root of 85. Don't forget to turn it into everything divided by 2. If you don't do that properly, what tends to happen is you'll get a slightly wrong number. Now this, my calculator says there is no way to simplify that. You just go to a decimal number. Because my calculator has just given me exactly the same thing I typed into it. Yeah?
No, but
Press the SD.
yes.
And you get what number?
2.1.
0.
2.11.
Let's go a bit more accurate first. Why would I go a bit more accurate at this point?
For later.
Yeah, just in case later I need to use the number again. That's the first one. Second one, what changes? Yeah, the plus now changes to a minus. You can do it by editing on the calculator, so it should be a bit quicker. Again, it gives me a different number, press SD, and now I get minus 7.10977. What can I do to check it?
You put it in the equation.
Yeah,
In the original.
you put it back into the equation here. So let's do this one. I'm going to use the memory, and I'm going to store that in A. So Shift, store into memory A. And I'm also going to go back and look for the other one and store that in memory B. So we've got on my calculator alpha squared, A squared,
15 is right.
plus 5 times A, and it gives you exactly 15, so that worked. Do the same thing with B, alpha B, plus 5, alpha B, and that gives me 15 as well. So both of those have just checked with the calculator by using memory A, memory B. And I can't remember who it was did that, but somebody did during the exam make a note of what memory they'd use in there, but it's fine. Just put it in a circle near the side. Someone might wonder what you're doing and then suddenly realise, yeah, you're just making a note of what memory you've used. So that's using the formula. Last one is completing the square, and I'll leave that at that point for the moment because I think you can do some of the questions out of the book. And it will be the textbook, so you might have to go and get the big thick textbook down there. Not yet. Give me another number, not number 3, not number 19.
11.
So you two are too slow. You jumps in there too quickly every time. So number 11. We've got e squared is equal to 6e minus 4. Number 11, there you are, right in the middle there. What's the first step?
Rearrange.
Rearrange, so we get e squared minus 6e plus 4 equals 0. Having a look at it, do you reckon you could factorise that one?
Yes. No.
Yes.
Think about the number. What are the factors of 4?
Yes.
2 and 2.
2 and 2. Do they add to give me 6 or minus 6? No. What else could there be?
1 and 4.
1 and 4. Do they add to give me 6 or minus 6? So factorising is not going to work for us. You could use the formula, but the question may stay, they may force you to use completing the square. If this says by completing the square, and you use the formula, that's not considered correct. Although technically, if an examiner tried saying that to me, I'd argue with him, because I'd turn around and say, but the formula is completing the square. That's how the formula came about. If you do completing the square on x squared plus bx plus c, and you do completing the square fully to get x equals, you wind up with the formula. There is actually, in my notes up here, a proof somewhere. I'm not going to find it now, I might find it later. So, let's go for another one. Where's my blue? So, to complete the square, what must happen for completing the square? What's completing the square create? Let's create a bracket that's going to be squared. We'll get a correction factor
Plus.
and a plus 4. And that must equal 0. So if you remember when you square a bracket, if I do x plus 1 squared, I'll get x squared plus an x plus 1. Well, the 2x's add together to give me 2x. So to create the original bracket, you take the number on the letter and halve it. So if I do half of this, I'll get minus 3. But when I did the x plus 1, I got an extra value. I did 1 times 1, which was extra. How do I correct for the extra?
You minus.
You subtract it, and it's minus what?
9.
Yeah, minus 3 squared. I'm just doing it that way round just to show exactly where it came from, but we always correct it. So we now get e minus 3 all squared minus 9 plus 4, so minus 5 equals 0. Rearrange it so we get the bracket. E to the minus 3 is equal to minus 5 to the other side is 5. How do I get rid of this bracket squared?
Square root.
Square root it. So I've done 2 steps in one. Bring the other number to the other side. Oh, what's missing?
U. Oh, wait.
Square roots. How many answers are there to a square root?
2.
2. What are they?
Minus plus.
Plus and minus. Yeah, that's where the plus minus comes from in the formula. When you do the square root, you get a plus and a minus version. Rearrange and we get 3 plus or minus the square root of 5. That's in an exact form. And then you chuck it into your calculator. Again, make sure you store it in the memories as well. 3 plus the square root of 5. Shift store A. And previous answer, but with a minus. Shift store B. And when I do it, I got B. So E is, second solution is 0.76393, and the first solution is 5.23607 if I round it correctly. Yeah? Check it, stick it back into the equation. So I'm using a squared. It's probably best to do the rearranged form now because I've got e's on both sides in the original and that's a bit awkward to deal with. So assume that I've done this correctly. Check it carefully. Yep. Now let's put a squared, alpha a squared, minus 6 alpha a, plus 4, and it gave me 0. So that A memory was correct. Check with the B memory. Delete alpha B. Delete alpha B. And I'll get 0 as well. So my B memory was correct. Okay?